Okay, welcome to the second last video in linear graphs, and this is simultaneous equations. Now, what are simultaneous equations? They are a way of finding, please excuse my crazy axes, where two lines intersect. So the aim of this is to find a single point which has coordinates. So we need to find the x coordinate and the y coordinate of a point where two lines intersect. Now, let's say this is probably the hardest topic in linear graphs. So I do want to give you an example of why this is useful. So let's say we're back to the burger shop the fish and chip shop that we introduced in the plotting video. And there's two different methods of making burgers. And instead of the y and x axes, there's a graph to show how effective the two different methods are. So this is the cost, and this is the number of burgers. Okay, and let's say we've got Bob's method and Betty's method. And Bob's method starts off with a pretty high cost because he's got very expensive machinery, but then it doesn't cost much extra to make each extra burger. Whereas Betty's method, it doesn't cost that much to start off with, but each burger is more expensive. If I make one more burger, it's more expensive. So that means the cost increases a lot faster. Now, we need to work out how many burgers we're actually making per day to work out which method is better. So it'd be good to find out where this point was of intersection. I'm just going to draw Bob's method and Betty's method. Now, why do we need to know this point of intersection? The reason is because if we know how many burgers are here, so if we know the x coordinate really of this point, this number, so if we know that, we know which method to use, because if we make more burgers than this number, whatever it is, let's say this is 25 burgers. If we make more than 25 burgers, then Bob's method is actually going to be cheaper. But if we make less than 25 burgers, Betty's method is going to be cheaper. So this is just one example of why simultaneous equations are useful. Okay, so let's get into the first method. We're going to be learning two methods of simultaneous equations. And we're not actually going to be using graphs to solve them. They're both methods involving algebra. So the idea is we can work out what the coordinates of this point are, x and y, without drawing graphs. Okay, so the first method we're going to use is called substitution, and that's what this video is about, and there'll be another video coming afterwards about elimination, which is the other method. So let's say we have two equations. Now this equation is one of the lines we were talking about, and this equation is one of the other line. And to find the point where these two lines intersect, we can solve them using this method. So I'm going to do something first, and then I'm going to explain why I did it. And I'm also going to explain how it's possible. Okay, so I'm substituting equation 2 into equation 1. And the result of that is x plus 3 times negative 2x minus 2 equals 4. Now, if you don't understand why we did that, that's okay. That's what I'm going to explain now. But first, oh no, actually no, sorry. That is what I'm going to explain first. This is really good. This is a lot better than the situation that we had originally. The reason for that is we have an equation now with only one variable, x. These equations have two variables, x and y. I'm going to show you why that's important. If I have an equation x plus 2 equals 5, I can solve this equation and you can look at this straight away and tell me, I know what x is. X is 3. X has to be 3 because that's the only thing that makes the equation work. But, so that's with only x, but if I have y here instead of 2, we don't know what x is because y is getting in the way. And so this is why this equation, we can't solve this equation and we can't solve this one, but we can solve this one because it only has x's in it. There's no y's anymore. Now the second question is, how did I do that? Now, how I did it was I got this equation and I just wrote this equation out, except when I got to y, I wrote some brackets and I replaced y with minus 2x minus 2. I replaced y with this because y is equal to this. I can replace y with that because they're the same thing. It doesn't matter what I can times 3 by y, or I can times 3 by this, because they're equal to each other. So this is really exactly the same as this. Okay. Now, this still might not make much sense to you, but we will go through and solve the equation. I think hopefully you'll see why this is useful by the time we get to the end. So let's do the next line, and the next line would involve expanding these brackets over here because we just want lots of terms that we can collect into like terms and to make this a little bit simpler. So let's start expanding these brackets. To expand, I have to times the first two, which is 3 times negative 2x. And I'll multiply the numbers together and I'll get minus 6x. Then I'll expand these ones. 3 times negative 2, which is minus 6, equals 4. Now, if I've got x, well, if I'm adding a negative number, that's the same as subtracting it. X minus 6x, it's really like thinking about how many x's you have. You have one of them and you're taking away 6. So you have to do 1 minus 6, which is negative 5. And that's how many x's I have. So I've got negative 5x. And we'll keep the number here. Okay, now we have to solve this equation. We just want x. We want to be able to say x equals something. Okay, and at the moment, we have more than x on the left-hand side. We've also got a negative 5 here, and we've got a minus 6. So we have to get rid of these two. So that's what we're going to do. Let's get rid of the negative 6 first, and we'll do that by adding 6 to both sides. If I add 6 to this side, it gets rid of the negative 6. And if I add 6 to this side, I'll have 4 plus 6, which is 10. So we've got negative 5x. We've just got rid of the 6 by adding 6, so that disappears. And then we've got 4 plus 6, which is 10. And finally, to get rid of this is negative 5 times x. And because it's timesing, we need to do the opposite of timesing to get rid of it. So we'll divide by negative 5, and then we have to divide the other side by negative 5 as well. Okay, so let's cancel these out. And we've got x equals 10 divided by 5 is 2. Now, because one of these is a negative, it ends up being -2. Okay. All right, so x is equal to -2 if I haven't made any mistakes. Now, I'll just check my working. I've done this before. The previous page. This says I have x equals 2, so I must have made a mistake somewhere. Unless I made a mistake originally. Let's assume it's that. All right, so x equals -2. Now what you do here is, if I know what x is, I can substitute it into one of these equations and find out what y is. Because if I substitute it, instead of x over here, I'll have a number. And that's a lot easier for me to solve the equation. So let's substitute it into this equation. Okay, so substitute into equation 1. It's really good to label your equations 1 and 2 because it makes things a lot easier. So we substitute it into equation 1. So we'll rewrite this equation. Instead of writing x, we write -2. And we'll just write the rest of the equation. Okay, now to get rid of this, we need to get rid of everything except for y on the left-hand side. So to get rid of this -2, it's the same as getting rid of this -6. We have to add, so we have to add 2. If we add 2 to this side, we get rid of it. So we're just left with 3y. And if we add 2 to this side, we get 6. So let's divide both sides by 3. And we finally end up with y equals 2. Now, at the start, remember I said we had to find the x coordinate and the y coordinate. A lot of people, when they're doing this, they get up to this point and they say, right, I'm done. I found what x is. That's great. But they've only done half of it. So we found what x is, but we needed to find what y is as well. So now we've found out what x and y is. Our answer is a coordinate point, which is -2, 2. X is -2, y is 2. All right, now every time you're solving the simultaneous equations, remember, you're finding a coordinate, which is a point that can be graphed on a graph like any other point. -2, 2. That is the point where these two lines intersect. All right, thanks very much for watching, and I'll see you next time with elimination.